Uh, Very good morning to all of you. First of all, thank you for choosing this session and being here today. A quick introduction. This is Satish Hegde, practice leader, AI, data and analytics within Cognizant. And Toyota is one of our strategic and very flagship customer especially within the manufacturing and auto segment. Today, I'm very honored to share this stage with Rajesh Emani, data and analytics leader within Toyota, to jointly talk about our fantastic journey on the Toyota unified Lakehouse ecosystem, especially leveraging Databricks, right? It's a fantastic journey, the long journey, but today we are going to focus especially on the very recent aspects of the unified Lakehouse ecosystem. And to start with, Rajesh is going to cover some of the challenges faced prior to this engagement, and then how Databricks solution levers helped to kind of resolve those challenges and also drive some of those business benefits, and also the current state ecosystem. And then I will also talk about how Cognizant partnered with Toyota in bringing a framework-driven approach in conceptualizing and realizing the architecture aspects, and also how it helped in scaling the journey, of course, right? And in the process, I will also talk about some of the frameworks in detail, and then Rajesh is going to conclude with the values delivered as part of this ecosystem, and also the next gen future vision, what we have as part of this continuous journey. With that note, I will request Rajesh to get started.
Thank you. Good morning, everyone. Like Satish said, thank you for attending the session and giving us an opportunity to Databricks. I'm Rajesh Imani. I'm a senior director responsible for data platforms and engineering at Toyota. My main focus and passion is about driving customer success. So with that in mind, I have a quick question. How many of you have driven Toyota or Lexus, either here or international? That's a good show of hands. Thank you. Thank you for being an excellent customer of Toyota. I appreciate that. With that, I will just step into the topic here. So as Satish said, we have had data lake for years now. We had on-premise and we have in cloud, but data lake in itself is not going to solve every challenge at the company, right? And that's what we're going to talk about. When we built the data lake, we celebrated triumph, but then the challenges didn't stop from arriving to us. So we were driven towards a lakehouse solution to be able to solve many other problems that we are not able to address just with the data lake. And there's a reason why we call it as unified lakehouse. I'm going to address it a little later too. The first premise I have here is I look at the three dimensions of my platforms team. The first being the business users, who are our data consumers, who derive insights, who make decisions. And the second is my internal stakeholders. Many of you may have experience too, like you work with security, you work with data governance team, you work with internal audit team, and sometimes they drive some of the solutions that you have to develop on the platforms. The third is my engineering folks, the people who create the pipelines, the people who create the data products. What can I offer to them to make them more agile? That's precisely the driver for some of these challenges here. We have had data lake built by sunsetting most of the data warehouses we had, but the journey didn't stop there. There is a need for faster analytics, real-time streaming analytics, that some of the groups at Toyota started building data hubs, siloed data hubs that power quality insights, manufacturing insights. Now, what is the outcome of it? You have data duplication happening across. You have data in data systems, data hubs, and data lakes. So it is difficult to manage. It's going to be more effort intensive, as well as you may lose some of the control about the data. Control is not a good word, but at the same time, at least better data management. We also had a lot of human-centric processes when we request for ingestions into data warehouses, set up data hubs, or get approval for data access requests. So the data stewards are under a pile of requests that they have to manage. And guess what? they can't make the right decision if they're not very well informed about what data we are offering to the users. The third is the time to data and insights. Typically, when you write Spark code, you all probably have seen, it takes few days at least. And the business users would want to have the data at their hands in a matter of hours or days. It cannot take weeks. So how do I automate my pipelines? How do I accelerate the data engineering's productivity so we can deliver data in no time? On the other side, in the last 2-3 years, we have seen explosion of AI and Gen AI type technologies. So the business wanted to tap into those technologies and deliver more powerful insights. They want to be more predictable about what can happen next. But the crux of it is you need the data to be vastly available. You need the data to have better quality. You need the data to be available at the time you need to power the insight. You also have the internal groups that I call as my audit groups. They chase us for being compliant with government regulations or audit findings. Many of you may have seen evolution of CCPA, CPRA, but how many of you have dealt with SOX compliance in respect to data lake? How many of you dealt with the fine-grained access controls that we have to share to our security because they need to know who's accessing data for what purpose? We all have audit log and monitoring, but you can't expect the level of granularity that sometimes the security team would ask. So these are some of the challenges that we have been driven by, not just fulfilling the Lakehouse as a technology platform, not just fulfilling the fact that we are delivering data to our end customers. So that helped us think about, okay, what else we have to do and what is available with Databricks versus anything else outside, which is what we're going to cover in the next few slides too. Fortunately, we partnered with Databricks and Cognizant that helped us address some of these challenges. But guess what? You can't fix challenges and sit quiet. You have business evolution happening on the other side. There is digital innovation happening in manufacturing at breakneck speed. There is smart factory coming up. There is IoT analytics coming up. So having a lake house or a unified lake house is not the end goal. You have to continue to innovate and solve for the challenges next. We also have seen supply chain disruptions since pandemic, and we also have seen the evolution of the autonomous vehicles. We also have seen the parts supply chain evolve. We had to solve for some of the supply chain challenges. The supply chain team wanted to know when a vehicle can be delivered. They wanted to be more predictable and accurate on when a part can be delivered to the warehouse or to the dealers or even to the assembly line for that matter, which is what led us to real-time insights in manufacturing efficiency. Unless the manufacturing people know what they're going to deliver next and when their parts are going to be available, they can't plan well, and they cannot deliver at the speed that the vehicles are being demanded for. As you all know, Toyota makes the largest number of vehicles on the planet, and we have to meet our customer expectations. So modernizing the supply chain and improving manufacturing efficiency is at the helm of it. But how can you do all of that if your lakehouse is only providing data? You have to innovate. You have to solve for the next puzzle. And as AI models and ML models are being developed, you need to make sure that the data is more accurate and more predictable for them. The last two, again, like security and compliance, you see on the challenges side, but there's a driver as well. From a compliance standpoint, you may have seen the recent challenges with tariffs. As the tariffs are being laid upon, the business needs to know what is the impact to the company. What should I do to react and save our cash? At the same time, be compliant with the regulations that we have to impose, that we have been imposed for. On the other side, Toyota being a large company, we have some research affiliates. We have connected car wings that we need to work across. So which means data has to be shared across these affiliates. But guess what? As you share more data, you're duplicating the data. You're probably losing some aspects of the governance too. So the challenge we were given with this business driver is, how do you share the data across with the least duplication and best security possible, that the users get the data they need, but you're not proliferating data, you're not losing any controls. So after we use Databricks to solve some of these challenges, Pardon me, I could not put more details because of the security limitations we can share here. But we did have unified Lakehouse, which integrated the data lake capabilities, data warehouse capabilities, as well as some of the data hubs. So in essence, we're able to solve the streaming and real-time needs for our analytics as well as batch, with data not being duplicated as much. We are powering 200 plus AI ML models that deliver predictive analytics across our business verticals. We have started setting up a clean room using AWS and Databricks tech stack combination. That way you can avoid data duplication. You can share data confidently and most securely to the end users. We have started adopting Unity Catalog so that we can avail the fine-grained data policies and centralized data governance. In our historical world, we are a mix of AWS and Databricks tech stack. So we had to use different security controls for sharing data to data scientists, different way of sharing data to the analytics users, SQL users, and different ways to share across the geography or affiliates. But that means that you are probably duplicating the security policies across, adding more effort on security audits as well as governance. So with Unified Catalog, we are able to centralize all the policy governance, and that way we can enforce security controls at one place. We also stepped up our efforts to develop observability and ops dashboards. Guess why? So you know who's using the data at what time, and if there is less usability of certain data, you can probably throttle down the pipeline so you can save the cost and optimize your TCO. At the same time, you need to know if there is any failure of the data pipelines, and we want to be the first persons as a platform users to know the pipelines failures before the business sees it. At the same time, we want to be the first people to know any quality or anomalies that seep into the data from the upstream before the business sees it. So we've implemented some frameworks and protocols that Satish will talk in detail so that we have end-to-end observability about the platform pipeline health check, about the security aspects, policy governance, as well as the cost optics. So I'm proud to say that we have integrated 300 plus data sources across 15 of our vertical domains. We have developed 85 plus data products using our data engineering pipelines. We serve data across 2,000 plus self-service users, plus we have developed a lot of models. The good part I want to call out here is the data quality checks. A year and a half ago, we probably had like about 5,000 data quality checks. It took us a lot of time using manual profiling methods to understand what are the anomalies that we see in the data, what type of quality checks we got to put in so the business gets the accurate data. But guess what? It is time intensive, effort intensive. So we started developing a scanning module that automatically detects the data patterns, identifies any outliers or anomalies, and gives us the input so we can create those data quality checks upfront so that business can see the data accuracy outside of it. So, like I said, we used a mix of AWS and Databricks tech stack. 2 years ago, our use of Databricks is merely Spark batch. That's about it. But I hope you all are aware of Databricks evolution too. We now are using Databricks SQL clusters for processing the data and serving the data. We use Databricks structured streaming for real-time use cases. We adopted Unity Catalog as our technical catalog across data footprint, which gets metadata from Lakehouse, warehouses, data hubs across. So it's one-stop shop for anybody to know what data you have available. It is the solution we use to implement fine-grained security policies so that security has one window of visibility of who's given access to what data. And it also helps us be compliant with some of the policies that are coming up. Delta sharing is the newest feature paired with Unity Catalog that we started adopting for our affiliate cross-affiliate data sharing. And this is the feature that we are using to help reduce the data duplication across the affiliates. So we have Connected Car, we have other companies that set up the Unity Catalog, exposes the schema, and we provide access to the data. So the users get the data they need, but with low cost of duplication or avoiding additional security lapses. Satish will cover some of the frameworks we developed to accelerate the platform features along this side. The data scanner tool is the one we use to identify the data quality checks, but we are also trying to identify the data classification rules. How can I know if this data has some confidential or highly confidential fields that I may have to add additional protection, like tokenization, etc., or maybe even create obfuscation mechanisms so you don't, by default, expose all of the sensitive fields to the users. So with these 4 components that we started adopting, I can proudly say we have stepped up our data lake and Lakehouse to an extent of using unified Lakehouse features. With that, I'll hand it over to Satish to talk about the technicalities of how we accomplished.
Thank you, Rajesh. Let me start with a question. How many of you have navigated through the on-prem data warehouse ecosystem, then big data and Hadoop, and then the kind of hybrid architecture on the cloud, and then most recently the unified one, right? Any hands here? Thank you. I think you appreciate this more than anybody because you would have already gone through the kind of challenges what you have faced in the pockets on all those journeys, right? The way how architecture evolved over a period of time from the on-prem world to the unified Lakehouse ecosystem now is a fantastic one. When we look at architecture, we look in 3 dimensions usually, right? And that is how we look the Toyota architecture also with our partnership as well in 3 dimensions. One is the conceptual building blocks, what you need to serve from the business driver perspective, what he talked about. Do we really have all the conceptual building blocks before we practically realize those things, right? Then the very important is while Databricks is on the center, of course, on the unified Lakehouse ecosystem, you also need the supporting tools and technology ecosystem at a periphery level to kind of bring the 360-degree view of the platform architecture much more controlled way and much more powerful way, right? That's why you will see a lot of partnership from the Databricks also to bring the 360-degree view of that one. And then, of course, as part of the Cognizant partnership here, we onboarded a lot of frameworks here to bring scale. Of course, a lot of reproducibility angle and other, to avoid all the redundancy aspects, and then bring productivity angle to it and to bring reusability angle to it, right? At the end, you also get the cost efficiency. So I'll give a little bit more color to the architecture in these 3 dimensions from left to right. You see on the extreme left, you see as part of any typical data and analytics architecture, you see all the varieties of data, be it structured data, unstructured data, or real-time data, batch data coming in from RDBMS data, then also APIs, files ecosystem, all those things, right? And then you kind of have the data onboarding ecosystem through some frameworks, be it a data ingestion framework or the data scanners, more for the discoverability of the data. And then in the process, you also use the powerful ecosystem of the tools, like for the real-time data, you might use Kafka ecosystem there. Then you can bring Databricks autoloader ecosystem and so on and so forth, right? And then, of course, you have the medallion architecture on the Delta table, which is silver, bronze, and gold ecosystem. And then as part of this, we also built some frameworks from the reconciliation features, which I will talk a little bit more detail in the next slide. Then we also have pockets of data ecosystem in the gold layer, like some of those aspects. You also see some redshift here because of some of the legacy here. And then in terms of the consumption side, you also have the data virtualization ecosystem, which is realized using Denoda, so that from the user perspective, you get a unified interface from the consumption so that they don't have to worry about where exactly the data resides, rather focus more on the experience part of it. And also virtualization layer brings in more security and fine-grained aspects as well. And in that process, we developed some of the frameworks as well, more from the virtualization side, which I'll touch upon some of those things. And look at the consumption, right? We have varieties of patterns. Some of those things Rajesh covered as well, mainly starting from the BI and the advanced BI, more in the exploratory way, standard BI, Then you have ML ecosystem, that is a separate platform altogether, but all the enterprise data to that platform goes from this platform. So that means it is one of the key sources for the consumption aspects of the data ML platform as well. Then you have some search consumption pattern, mainly Solar and OpenSearch ecosystem, considering it is AWS ecosystem also under the hood, right? Then there are some Power Apps sitting on the Delta tables, more on the app workload. Then you also have some of the data collaborations, the most recently touched upon, Rajesh touched upon some of the data sharing and clean rooms aspect as well. So it is like you see almost all the varieties of consumption patterns here. And then use cases, of course, revolving around IoT analytics because of the real-time data, then some of the manufacturing and supply chain use cases, then some maintenance and warranty-related use cases. All those aspects are getting realized. And then horizontally, you see all the powerful frameworks and capabilities. This is where we brought in a lot of frameworks around data quality, then the CI/CD related aspects for the platform, and then also some of the common utilities frameworks, right, which I will touch upon a little bit in detail in the next slide as well. So you have seen this architecture like in three dimensions, right? I'm going to do some deep dive on the third dimension, which I talked about, which is especially on the framework part. And this is where we brought in a lot of value in our partnership, right? Which brings a scale, because when you are looking at the big engagement, the first and foremost thing you need to make sure is you don't create too many silos and redundancy aspects. Bring all these modular components together and then create a framework-based approach so that you bring all the bells and whistles for the scale of your platform as well as for the entire execution and the journey, right? So let me touch upon some of these things. The data scanner is basically or the quarantine framework, which you call here, is basically when the data gets landed, right? The scanner actually scans the data and then identifies all these sensitive elements and PI elements and those kind of things. And then if it finds, it then alerts the data steward so that they can come and look at and then review the data and then post their sign off. We use the protectivity-based tokenization ecosystem to kind of move the data to the next layers. There are some aspects of data ingestion frameworks also comes in here, which is autoloader based configuration, again for the first time load or even the incremental load aspect, right? In parallel, there are some custom frameworks also which we developed using SHA-256 algorithms and also leveraging some of the Spark code to kind of bring all the aspects of some of the regulations he talked about as well. Very recently, we started looking into DQX framework, the Databricks based one. I think some of you might have already started experimenting on that. That's a very evolving framework, and we see a lot of promising future as well there. We brought some ML-based discovery capability for the scanner ecosystem. Presidio is helping a lot within the DQX ecosystem as well. Then you can see some of the data transformation related things. Basically, when you look at the data supply chain, you bring all these common modules which are applicable and then stitch it in such a way that you bring that experience of modularity, right? So throughout the data supply chain, that is the power of the data transformation framework so that you can bring the more scale to the execution. Then the reconciliation framework is a part of the larger audit balance control framework, because the most important thing in the data supply chain is to make sure that you bring the consistency checks at every layer while the data moves along the chain, right? So you don't want to have a situation where source data is one, when you land it, you miss some of those elements and then you kind of get into issues from the consumption side. So that framework actually makes sure that it kind of validates at each point that you didn't miss any data and you bring consistency checks into that one. Then virtualization framework is where we automated some of the views, which I mentioned Denode also, right, as part of the virtualization, so that from the Delta tables, you create some automated views depending on the consumption needs, and then have it ready for as a base views or the surface views from the Denode angle. Then the common utilities are more around for the support ecosystem, not as part of the transformation ecosystems, like revolving around all these Delta table ecosystems, creating, deleting, updating, doing some cleanup operations, repair operations, or it could be some of the performance optimization related stuff. So when you package all these things, there is a centralized hub, and then you know that there is already an asset and you don't have to reinvent the wheel for some of those stuff, so that you kind of centralize all those common utilities and then you bring the productivity aspect there. The most interesting one is the CI/CD framework. Some of you, if you have already experienced the CI/CD framework outside of the data ecosystem, and then if you get into data ecosystem, then you understand what exactly is difference here in the data ecosystem, right? So typical CI is almost at the same thing like enterprise level. Here it is GitHub Actions we used. We had Jenkins earlier, and then we moved to GitHub Actions. But when it comes to CD part is where it gets a little bit tricky in the data world, right? So here you kind of, what we implemented here is more of a YAML configuration based file. It talks about Databricks runtime, Spark ecosystem runtime, the configurations, then some of the cluster configurations, autoscale related configurations. And then that file goes as an input to the module where you call the Databricks jobs API, and then it gets, the job gets created and configured in the Databricks cluster, right? And then at the same time, because of the latest and greatest Scala build, what you commit through the GitHub, then it gets pointed to the S3 bucket where you have the latest and greatest build file, so that you get the 360 degree of the CD. So that's one key thing which we implemented as part of the data engineering ecosystem CD. The last but not the least is around the data quality. Some of those things Rajesh touched upon, but the key thing here is look at it is in three aspects, right? One is you need a rule ecosystem, which is configurable and more of the user can also enter what rules are applicable. Then there is an aspect of ML-based rule generation where you can recommend, due to some of the discoverability aspects on the sample data profile, while profiling the data, you can bring in ML-based rules also. And then when you execute these rules, of course, there will be some outliers. And when you execute, those outputs and the results can get flagged and stored into another table also, right? And then you bring in the powerful UI ecosystem and the Power BI ecosystem to kind of monitor all these quality things, whatever is going on. So there are a lot of other frameworks like FinOps ecosystem and some of the data validation ecosystem during migration and all. That and all also we onboarded as part of this one. So think this, right, when you look into all these things, it is where you get the power of the scale, right? So that's what I want to highlight. And again, I will give it back to Rajesh to talk about some of the value we delivered as part of this platform, even through these frameworks, and also some of the future thinking we have as part of our continued journey. I'll give it back to Rajesh.
Thank you, Satish. I take this opportunity to thank Cognizant and our Databricks partners as well, because without them we couldn't have achieved a lot of the success he's talked about. The challenges we had seen, the business drivers we had seen, I can proudly say we're adopting Databricks Unified Lakehouse, adapting Databricks features, as well as with the frameworks Cognizant has developed, we were able to achieve most of them. And our business is very happy in adopting our data lake too. So technically with the frameworks such as talked about, we are able to accelerate the pipeline development. What used to take several weeks, like developing complicated pipelines, is now a matter of days, less than a week. We can deploy and using the DevOps solutions that they mentioned about. We're able to improve the query performance by bringing in the data hub concept, by bringing in the SQL powerhouse as well. With all of these, we are able to now solve a lot of unpredictability in supply chain and the analytical insights that they needed. Today, our dealers are happy to see a narrowed window of time the vehicles could be delivered so they can promise their customers about it. What used to be a matter of months across or a lot of time unknowns, we're able to give predictions to a window of time that they can accurately and confidently sell the vehicles. We're able to improve our parts supply chain predictability with an end-to-end 360 view of the lead time it takes to secure and procure the parts from our suppliers to our warehouses to our manufacturing plants. Our manufacturing folks are able to have a 360 view of the internal logistics that we have when the parts arrive at the docks to the assembly line, If an engineer on an assembly line is falling short of the part, the analytics team would know within a matter of few seconds, and they can replenish the parts so the plant line is not stopped. We have a full view of the data quality across the manufacturing and logistics and supply chain pipelines, but we also have analytical insights into the vehicle quality at the manufacturing shops. So we can prevent some of the quality issues from seeping in and thereby reducing the fallout of warranty claims once the vehicle is sold. There is a full view of the quality aspects of the vehicle at every station that the vehicle is moving into, and these are almost real time in many aspects. And trust me, it is not as easy as we say here from this dais, implementing such systems and solutions across 12 of our plants across US geography. And most of the times the plants have disparate products and vendor tech and machining solutions. So it is difficult to get all of the data being integrated and all of that to have the same semantics that the users can understand and interpret. And that's exactly where, like I mentioned, the Unity Catalog and the semantic layer is helping us. I can proudly say we are now fully compliant with SOX audit controls. And trust me, you don't want to take the risk of implementing such controls across the platform because not all of them would determine it. You're going to be wasting a lot of resources and lose some optimization. So we have carved out the pipelines, and we have carved out a process where this specific pipeline or this specific data set has to have SOX controls, and those will be applied automatically. So our audit groups have visibility to what's happening across, and we are fully compliant, thereby avoiding fines and regulatory flags. We have also implemented a lot of trade volume reconciliations across our North America geography, where we import a lot of parts and vehicles. We have full reconciliation, and our compliance and trade team are fully informed of what it means to respond to tariffs, because they know how many parts we are getting from which country and how many vehicles we are importing at what speed. So they can adequately plan ahead for paying the tariffs or avoiding the tariffs or being at the most compliant to the regulations that come through. What used to be taking months to do the exercise of reconciliation and being compliant is now a matter of weeks because of the powerhouse we are solving with the Lakehouse here. The clean rooms we have developed have minimized data duplication, have nearly zeroed out any exfil risks for data, which is confidential, but yet powering the users to do what they have to do and get the insights they needed. But like I said, the road doesn't end once we accomplish a goal. We still have future needs and drivers that are running us behind. We want to improve the accuracy of the data scanning tool that Satish mentioned about. Right now it stands at about 60 to 70%. We want to be at least at 90% accuracy to say this specific column or the field is sensitive or confidential. So the stewards can flag them for additional measures. We can add tokenization and additional protection to those. We wanted to automate ingestions for non-sensitive data. If the data is non-sensitive, you can perhaps cut short a lot of governance process and steps, but do we really need to spend the days I mentioned about ingesting the data? Is there a way to automatically create a pipeline and solve it for the analytical users? The other challenge I want to mention, which is close to my heart, is Gen AI use cases. I'm sure you all are excited about the adoption across, and you are all here to learn about what is happening in Gen AI world. But trust me, we are already adopting Gen AI for most of our unstructured data sets. But guess what? You have use cases coming up that requires pairing that unstructured insights with structured data sets. I can quote an example where a contact center agent is speaking to a customer, and they are already using Gen AI to look at the past transcripts and deliver some insights, and they be able to speak to the customer to the problem they're talking about. But guess what? They're missing a ton of insights we can tell them from the data we already have in our structured lakehouses about what issues this specific vehicle has been noticed to, how many warranty tickets we have fixed for this vehicle. Maybe that adds a little bit more context when they talk to the customer about it. So we are working towards solving a use case, such use cases, and developing hybrid vector search, where you can scan your transcripts, where you can also scan your structured data to be able to combine and deliver more powerful insights. And Gen BI as Satish earlier touched upon. We want to power the analytical users to be able to use natural language to get their insights. Obviously, Databricks has Genie, but we already have other tech stacks. So we are trying to see, rather than relying on the end tech stack, which is Power BI or Tableau, how can the Lakehouse create an interface for them that they can query and get the insight they needed to, rather than using another BI tool. With manufacturing and IoT adoption, we're being challenged to deal with much bigger data sets, going into petabytes of volume of data. Also provide image and video analytics because they're adopting a lot of image-based sensors that we need to scan and detect any anomalous patterns or quality issues up ahead. And most of these are solved by some of the third-party niche vendors. But guess what? I cannot pay for 100 other products. I already have the data in the Lakehouse. So we wanted to bring in some of those analytics inside the Lakehouse. Lastly, I can solve for all of these challenges, but I also am challenged by the budget. So I have to make sure our platform costs are still low. We're optimizing the solution with frameworks and automations, thanks to our partners here. And lastly, to be able to offer citizen development with low-code, no-code tools too, so that we can accelerate our adoption much faster. With that, thank you for the time and opportunity here.